Okay, this is our introduction to microscopes. So here's some lab safety important stuff for you to know. No eating or drinking in the lab at any time. Learn how to transport all materials and equipment safely. Don't lift any solutions, glassware, or any other types of apparatus above your eye level. Do not leave your assigned laboratory station without permission of the teacher. Work quietly. Okay, read the assigned experiment before you start to work. Okay, follow the procedure. Do not begin unless the teacher tells you to begin. Okay, long hair, beards, stuff like that should be tied up, tied back. Do not wear loose-fitting clothes or jewelry. Okay, so here's our little mini microscopes unit. Okay, so here's our microscope. Okay, you have a light microscope, and there are different parts to it. Okay, and it's showing the nose piece accidentally here, but this is called the nose piece. You're going to have to know all parts. Okay. The body tube, the 4 by objective lens, okay, the 10 by objective lens, the 40 by objective lens. These are our stage clips. The diaphragm is down here. The illuminator, or light, basically. The eyepiece, the arm, the stage, the coarse adjustment, the fine adjustment, and the base. So for parts of the microscope, the eyepiece is the lens closest to your eye. Okay, so the eyepiece. High power objective lens, the longest of the 3 lenses, close to the slide. Low power objective, the shortest of the 3 lenses, closest to the slide. The tube, okay, gives the distance between the eyepiece and the objective. Okay, so I'll give you a quick. Okay, so the one that is shortest, and the one that is longest. Okay, so the 40 by is the longest, and the shortest one is the 4 by. Okay, so this is the low power objective, the high power objective. This would be the medium. The tube, or body tube, right here. Coarse adjustment knob, okay, is the larger of the knobs, which moves the stage in order to focus. Okay, so this moves the stage in a big way. So right here, this is the coarse adjustment knob. The fine adjustment knob, oops, smaller, this is the smaller of the 2 knobs, used to focus under high power. Okay, so when you're on high power, use the fine adjustment knob. The base holds up the entire microscope, right? So here's our base that holds it up. The arm holds the tube and the lens and connects the base. Okay, so here's the arm. The revolving nose piece holds the objective lens and turns to switch from one to another. Okay, so here's the nose piece, and this is what allows you to turn those rotate. And then the mirror, or the light in our case, reflects the light into the tube. So here is our illuminator, or our light. Okay. The diaphragm is a circular disc that controls the amount of light passing through it. So this is the diaphragm. This is what is going, so the light is shining through here. It'll it'll have different sizes that it allows different amounts of light through. The stage, okay, which is a platform for the slide to rest. An opening in its center lets light pass through it. Okay, so right here, on the stage. Okay, the stage is that whole thing. Um, and then the clips, and the clips hold the slide in place on the stage. Now you'll notice that this particular one just has 2 stage clips. Okay, some of yours will, some of yours won't. Some of yours have a little spring-loaded doohickey that holds the slide in place. Please don't overextend that when you're putting the slide in, and be very careful with when adjusting the knobs to center your slide. They are a um, plastic, and they can wear out very easily. Using a microscope. So to carry a microscope, one hand on the arm and the other on the base. Okay. Lenses should be cleaned with a lens cloth only. I will provide those for you. The piece of glass on which the specimen sits is called the slide. Okay. The smaller piece of plastic that is placed over the specimen is called the cover slip. Always bring a specimen into focus using the coarse adjustment knob. Okay, and when the specimen is in focus, turn the revolving nose piece so that the medium objective lens is in place. Again, bring the specimen into focus using the fine adjustment knob. Okay, never use the coarse adjustment knob to focus a specimen under high power. If you do this, it's likely that the slide will break. Why will it break? Because you'll be too close to it and you will crush it. So please make sure you do not. Only use the fine adjustment knob when focusing a specimen under high power. A microscope should always be put away with a low power objective in place. Okay, so make sure you switch it back. At the end of the microscope lab, the slide should be washed with soap and dried with a paper towel. The slip covers can be put in the garbage. Okay, so those little slip covers, they can be put in the garbage. Be very careful with them. They can be sharp. And when washing, we've got 5 sinks around the room with soap around all of them. And there's paper towels and paper towel dispensers. Please wash them accordingly. Okay, so how does a microscope magnify? A microscope makes things look bigger, right? Obviously, you know that. It does this because the light coming from the object passes through lenses. These lenses magnify the object. The object being viewed is on a microscope slide. Different lenses magnify different amounts. The object is magnified in 2 different places. First, through one of the lenses on the rotating nose piece, and then through the eyepiece. So if you had your microscope in front of you, I'd be getting you to answer these questions. But since you don't, we'll go through it together. We'll go through the math, okay? What is the magnification of the high power? Okay, it is 40 times, 40 by. What is the magnification of the low power objective? That's 4 by, okay? What is the magnification of the medium? That's 10. And what is the magnification of the eyepiece? That's 10 as well. Please write these down on a piece of paper so that you can go through the math with me as we go. Okay. To find the magnification power of a microscope, multiply the power of the eyepiece lens by the power of the objective being used. Most eyepieces have a magnification of 10. Ours do, okay? Use the highest magnification, pardon me. Using the highest magnification, objective, which is 40 pi. Okay, that means that you would be enlarging something 400 times, right? So you take the eyepiece, which is 10, and you multiply that by 40, which is the objective, and you get 400. So that is how you get magnification. If you're doing it on the medium, it would be 10 times 10, which is 100. If you're doing it on the 4 by or the low, it would be 4 times 10, which is 40. Okay.